I'll just give a basic overview about the onboard diagnostics that I have left last week, means the last class. And then I will be going with engine management system. Okay. In engine management system, we'll be covering the sensors, actuators, and then some of the calibration aspects. So these are the things that it covers in onboard diagnostics. So we have, as per the syllabus, you have OBD 1 and OBD 2. Basically, onboard OBD stands for onboard diagnostics, and currently we follow OBD 2. In earlier we have the OBD 1, which is the first version. Now this is the advanced one, and we'll see what are the key features of OBD 2, and then what are the requirements, and what does this mean for, and what are the disadvantages we will see. And just skipping some of the slides due to time shortage, and again you will also be studying this topic in an automotive control system as well. So you don't need to worry about that regarding the knowledge what you're going to get out of this. Okay. And this OBD is not a new one, okay? And as I said, initially we had OBD 1, and now we are going with OBD 2. And this was invented earlier 80s to diagnose. The main purpose is to diagnose the system. It's complete vehicle system. It's not only restricted to engine. It also helps to find out a way forward for the other systems like chassis, body, and then the brakes, etc., and even the transmission, power systems, etc. So it's not only restricted to engines. And now here we are going to see mostly about engines, how this will help to diagnose the problem which the engine is undergoing with respect to the vehicle of all category. And this OBD1 had some of the limitations that was being overcome with the help of OBD2, and this OBD2 regulations has been developed to maximize the benefit, which will help for the regulation norms as well. Basically, now we are going with Euro 6 in India, and Euro 6 is already there in Europe, and they are moving towards now Euro 7. And this OBD2 will normally help for helping out to ensure that the emissions with respect to carbon monoxide, hydrocarbon, NOx, particulate matter, all these have been met. Even the smoke limit, fuel consumption, all these have been met considering the norms and the specification what have been prescribed by the authority. Okay. So these are overview about OBD2, which will tell about the history. It's a self-explanatory thing. You can look into it. I have uploaded this document in Backpack in Impartus. You can also have a look over it. And this started by federal government in USA, and the model of this OBD was been based during 1994 in USA, and this had been applied to all the vehicles like light duty, medium duty, even heavy duty. And this is, as I said, this is basically to ensure that to diagnose the vehicle problems. Okay, so the OBD2, what I said is advanced one. It has been highlighted with DLC, which stands for data link connector, and this is easily accessible for placing it. And this will also help for determination, and also this also helps to record the status of the emission control systems. So as I said, this is also applicable for vehicle. So as we are dealing with engines, so basically emission control system is one of the key aspect of this onboard diagnostics. And this also have a malfunction indicator lamp, shortly called as MIL, which will help to eliminate the indication of the problems with respect to the engines. And the other feature that what you have is in the case of onboard diagnostic is DTC, which stands for diagnostic trouble code. So you have a lot of codes. You have separate codes for engines, frames, chassis, body, brakes. So with respect to the particular code, you get the trouble code, and it's not only the trouble code you get, but also you can also find out some of the solutions. On what basis you can also eradicate that particular problem using the code. So this is not only help you to find out or indicate the problems, but also it gives you a solution. Say for example, if in case if you experience any leakage or any malfunctioning, it also helps you to indicate the problem, but at the same time, it also helps you to give solution like to replace a hose or to replace sensors or to replace to check any wires which are loose, which are on loose. So this helps you to give a overview about the solution as well. So as I said, the DLC is very important, which stands for data link connector. I will show you the help of a picture. And you also have the protocol, communication protocol using a CAN, which stands for controller area. I will also explain that. And okay, so this controller area network, shortly called as CAN, is nothing but a communication system which will operate with the help of a wires in a data link connector. And this, as I was telling, this OBD2 is advanced from the DLC what has been used in the case of OBD2 is much faster in terms of the communication in comparing to the OBD1 protocol and what was had already. And in the case of a vehicle which is having more than 200 data, which will monitor and give you the results using the controller area network. Okay, so this is the DLC, stands for data link connector. This is the configuration of controller area network, which will use different pins. And here, what I mean shown is um, the pins having a different configuration, pin 6 and pin 14. And you have different connectors for the different thing like chassis, batteries, for a ground. You have different pins for the different application. And a number of pins also vary with respect to the different connectors for a different application. And you also need to follow some of the standards. For example, SAE standards you have, for which you need to ensure that all the standards are being met to ensure that the OBD2 is working fine with respect to all the requirements that have been mentioned as per the regulations and also as per the specification. Okay, so you see where this DLC is been located. Okay, it is hard. It is a theory part that you can look at it. So, and this DLC is located near to the pedal where the driver operates the vehicle. So it is nothing but the data link connected DLC. So they plug into it, and they have the tool called the scanner tool. Using that, they can also look for finding out the diagnosis activity for a vehicle. Now we are dealing with engines, so basically you can do the engines as well. Even the location of DLC can also be vary, but mostly typical what we use is near to the pedal of the driver. It can be sometimes even at the back seat as well. It depends from vehicle to vehicle. Even some of the vehicle will have the DLC location in this area. Cities is some other vehicle. Even this can be done like this. It can also be covered using a port. Okay, as I said, this is mostly for a communication related thing. So it will help you to find out different issues and different thing, like say for example, if respect to engine, if you have any misfiring in one of the cylinder, it will help you to give the alarm. And with respect to fuel system, with respect to the catalyst, as I said, you have a lot of catalysts for different emission control technologies. You have catalytic converter for a gas engine, DPF, SCR, LNT for diesel engine. So the catalyst performance is very much important for you to achieve the emission norms. And if the catalyst is not performing well, or if the temperature, because even to perform the catalyst, you need to ensure that the temperature is going to reach at a particular level. If in case the temperature is not reaching at a particular level, then you will also get indication with the help of the scanner tool, and again the corrective actions can be taken. Even sometimes even the catalyst may not work. Okay, sometimes the efficiency of the catalyst itself may be a problem, because say for example, even the catalyst is also having a lifetime. Okay, so during the course of operation, if in case the catalyst performance is not good, then you will get an alarm indicating that you need to look for the adding up of the new catalyst, or replace the old one with a new one. So it will give you an alarm even with respect to the catalyst performance as well, because the catalyst is very much important for the oxidation and reduction, that in turn will help for reducing the emission of carbon monoxide, hydrocarbon, and nitrogen oxide. And you have a lot of other status which is been shown in MIL, which stands for Malfunctioning Indicator Lab, and accordingly you can also take corrective actions. You also have the evaporator system, and you also have the air system. You have oxygen sensor, you have heaters, you also have the EGR, which have been used for the emission norms to reduce nitrogen oxide emission. So you have a lot of things with respect to the engines to find out the fault. So this helps you to monitor both continuous monitoring activities and also non-continuous monitoring activities. So some of you see some of the non-continuous monitoring activities with respect to the emissions includes the sensors of oxygen, catalyst sensors. You have the evaporation system and the EGR system. You also have the secondary air system. And with respect to the vehicle, so we have the heated catalyst and also the AC system as well. These are the most theory that I'm not going to cover, but I have uploaded it. You can have a look over it for understanding in depth. Okay. So three-way catalytic converter is the one which is used for reducing carbon monoxide, hydrocarbon, NOx. Okay. And you have the catalyst monitor with the help of, you can also do the monitoring activities with the help of the OBD too. So this is the graph which indicates catalyst performance, and you have the PCM, which stands for powertrain control module, which will monitor the catalyst performance with respect to the temperature and also the efficiency. You would have seen the efficiency graph. Carbon monoxide, hydrocarbon, and NOx should be higher than 90 to 98% at least, close to in between 90 to 98%. If in case if the efficiency is going drop down according to the lean or rich mixture, so it will also give you indication with respect to the emission point of view also. Okay, suppose if you also getting some misfire into the engine, you'll also get an indication, and according to that, if in case if it is a misfire, then what happens is the force on the piston goes down, and the speed of your engine goes down, which means the power output is also going down. So you will also get an indication. So if in case the fault, if the engine is not picking up speed, then you will also get indication that because of misfire monitor, you are have experiencing this problem. We also have the fuel system monitoring one. So based on the feedback with respect to the powertrain control module, this fuel system monitor will help with the help of MIL, stands for Malfunctioning Indicator Lab. to ensure that the fuel system is performing well. If in case it is not performing well, then you can also take corrective action accordingly. And you have rich mixer, lean mixer. According to that, the code, which stands for diagnostic tool code, will vary with respect to the different environment. So this is the malfunctioning indicator lamp, stands for MAL. So you have the lamp like this. So in case you get a light to check engine or to service engine food. So you will get the indication, accordingly you will take corrective actions. You have different criteria for the illumination lamp that you can also look into it. Basically, this is the main application to alert the driver to ensure that he or she is doing the repair activity considering the malfunction, so that the performance can be done in a more perfect manner, and the effectiveness can also be done at the appropriate time. Okay, so this is quite interesting graph. Stands for the onboard diagnostic graph in respect to the mileage and also the percentage of usage. Okay, so you see here the x-axis is the mileage in terms of thousand. So when the mileage is getting increased, say for example beyond 1,40,000 kilometers, this is indicated in miles. I'm going to convert that in terms of kilometer. So beyond 1,40,000 kilometers, you may experience some of the failure with respect to the vehicle. Okay, for which you also need to have the indicator lamp to ensure that the failure is not going to happen. And if in case any failure, you can also diagnose using it with the help of OBD2, and accordingly you can also take the corrective actions. So the MAL rate, the usage of MAL rate is also getting increased. Percentage is getting increased. Okay, so when you're increasing the mileage of your vehicle, which means as the durability or the variability of the vehicle is increasing with respect to the miles or with respect to the age of the vehicle or the duration of the vehicle, so you're also going to increase the rate of the usage of MAL. Is the graph which again shows that the mileage increases the percentage of use. This is with respect to the powertrain control module alone. Similarly, you have different control module for body, chassis, and different system is having different control module. One such module is the powertrain control module, which are using it for engine application. So this is the indication that you get. Even if you're going to, the oil pressure is going to be lesser, or you can get all the indication also. And the oil temperature is going higher, the fuel level is going lesser. The indication you will get it. Okay, this is very much important. See, the knowledge of this MAL is very much important because you should know the purpose of MAL. So, and again, what actions you need to take it accordingly, you should also know. You see, the immediate breakdown, you should not get fear that because of light indication that the issue is very heavy. So, you should understand what the indication is all about, and accordingly, you have to take correct action. So, accordingly, you should also, the driver should not get confused that is it the immediate breakdown or is it because of overheating, or you need to have the routine maintenance. So, here, what is important is you should understand the type of activities that the driver have to take according to the indication that what you're going to get out of the MAL. Okay, so this is the DTC, which stands for diagnostic trouble code. As I said, you have different diagnostic structure for a different application. So what has been shown here is with respect to the powertrain. The P stands for powertrain, and similarly different system will having different names. And this is the code. According to this code, you can take fault in it. P0101 stands for mass or volume airflow range or a performance problem. So if this code comes, you'll get a problem with respect to this, and it's not only the code you will get, but also the solution, how you can eradicate the performance problem or the range problem. Okay, so you will also get the solution out of it. It's not only you are going to have only the code alone, but also the solutions. See, these are different codes that you have. As I said, you have different things like for misfire. For misfire, it is P0300. If the system is, if the fuel is too rich or the fuel system is too rich, then you get this code. And again, these are the top 10 tools are called diagnostic trouble codes (DTC) that we are going to use for an engine application. It contributes to almost 9% of the other codes. And even for a low catalyst efficiency, you have code P0420, and EGR flowing. So you can see if the EGR flow is insufficient, then you get less, you get higher marks. Okay, you get higher marks. So you get an by putting that DTC, by plugging the DTC into the scanner tool, you can also get the indication that the EGR flow is insufficient. Accordingly, you can also modify based on the solution what you're going to get out of that of the OBD. And okay, so these are some of the comparisons that you can look into it. Okay, you have different rank accordingly also. C indicates its performance with respect to the tailpipe, and again you can also find out the, the system, whether the system is pass or fail with respect to the OBD2 itself. Okay. It is one of the code called P0303, which is because of the misfire in an engine. And see, using the MIL code, what you're going to get is you're going to find out the misfire is because of the cylinder number 3. And when you're removing this, you can also find out the cylinder 3 cover, it gets corroded. Okay. So the fuel system, what has been used in the system in the cylinder 3 is getting corroded. That's the reason it is having the misfire. You can also correlate, also take corrective action accordingly. See, this is how that device, what I told, for plugging in, you have the device for finding out the fault. Is the location basically is one location. Okay, it is not necessary that you should have the location similar to all the what is shown here. Even you can have it another location as well, but it will be better if you have it near to the if you have near to the vehicle or the foot of the driver. Okay, so you need to turn the ignition to ensure that the content you are going to have, and when you are checking it, you should also ensure that you are going to shut the headlights down, and also you are not going to empty your accumulator as well. So these are some of the precautions that you need to take care. Even you can connect using your phone also. Okay? I'm not sure. I think many of you also work in OBD. Yes, you are working in companies. You can also see that your engineer is also doing some of the fault checking using their own mobile as well. You can also connect it using your mobile of the location, and then what you have to do is you have to also install the app. You also need to connect that to the Bluetooth, and there is an app called Torque. Okay, even you can also put that, and then you can also find out the diagnosis. The person how he is using with the help of the phone, mobile phone. And also whether you have done some of the OBD2 with respect to your lab or not. You can also type me in your chat box whether the OBD2 anything you have done with respect to your lab. You can also, you see, it is very much important. Okay, you can buy the top app, that's this app, and you can also install it and also you can put that with your vehicle. It is the top engine management diagnostic tool. This is how it looks. See, there are fault codes. Okay, so if in case any fault, you will get the indication. It is going to process. It will take some time. Here there is no fault codes. Okay, it means everything is perfect in this vehicle. Okay, if in case any fault code, okay, there are different fault codes what I have told. So accordingly, you will also get an indication. See, it is the P0101 is one of the. It stands for mass or volume airflow, which I was showing. So this will also help you to tell which vehicle it is for different application. This also help you to ensure that it also gives a solution for that. Okay, so to check the wiring, to check the connectors for damage. So this also give you an indication respect to the fault as well. Okay, different fault codes also is been explained here. This is the DLC code and CAN coast area network. This is how the configuration looks. You have the 16 contents and each having the standards. So here J1962 is there. So you see 1 to 16 is having a different application. Okay. For battery you have pin number 16. For signal ground you have pin number 5. For chassis ground you have pin number 4. So I also told you about this different names for the different things. Okay. So accordingly you have the codes. So you have basically 4 characters, and each character will have the different indication. First character can be the manufacturing thing. The next character can be the system point of view, and next the fourth and fifth character can be with respect to the component been that is been there with respect to the specific code. Say for example P0302, it is having P stands for powertrain, and the 0 stands for the type of code, and it also helps you to identify the manufacturer specific code as well. And the 3 stands for the subsystems, which the subsystem belongs to. Powertrain, which system it belongs to. In powertrain, you have a lot of systems. Okay, you have engine, transmission, and even in engine, you have a lot of systems. And the 02 last indicates the specific code that is respect to the exact problems. So these are the topics that has been covered with respect to the sensors, actuators, engine control units, control system, software architecture, torque control, and calibration tools. So I'm not going to cover this topic. I'm not going to cover this topic. Software architecture I'm not going to cover. I'm going to cover an overview about the remaining topics. Okay, and again, it is similar to the onboard diagnostics, what I told. We have different sensors and actuators for not only for test weight engine but also complete vehicle. Even you will study some of the topics even in automotive control system as well. But in engine management system, more in depth about the engine sensors, engine actuators, those things. Okay, you have oil sensors, you have oxygen sensor, and with respect to engines, you have a lot of things, okay, to find out the fuel level. And but with respect to vehicle, you have different thing. Okay, these are the key engine sensors. Have oil sensors, fuel gauge sensors, oxygen sensor, throttle position sensor, crankshaft position sensors, manifold absolute pressure sensor, engine coolant temperature sensor, off-shaft flow temperature sensor. So you have the sensors, which basically the key important thing sensor includes oxygen sensor, oil sensor, fuel gauge sensor. And this is the oil oxygen sensor, which will compare the exhaust oxygen level and also the outside the air level. Because air contains oxygen and nitrogen, oxygen is required for you to burn the fuel for the combustion to take place. You need to have the required amount of oxygen, and this oxygen sensor will also help to ensure that the oxygen level is being maintained for combustion to take place. So this is the configuration, or this is the layout of the oxygen sensor. It is type is heater table type. It is having a heater element. It is having the cell housing. It is made up of a element called zirconium dioxide ceramic sensing element, and this is the cut section of oxygen sensor. And the next one is the oil sensor. This is how it looks. And this oil sensors is also called as oil analyzers sensor. They are used in automotive application, basically to sense the oil level in the vehicle. And it also helps for checking the contamination in the oil. It will also help you to sense the particulates, or it also helps to find out the viscosity and the temperature, the oil temperature, because you're also getting the alarm. The oil temperature is going higher, oil level is going higher, you will get an alarm. Basically, that is the help of oil sensor that what you have. This is how it looks, oil sensors, and you have different connectors. Means you have different type of connectors for this oil connectors, oil sensors. This basically will also help you to find out the oil pressure as well. But it also helps you to indicate. Okay? You also get an alarm. The oil pressure is not within the specification. You get an alarm, even the temperature. Those things, even when you're testing in testing the engine, you can also find out. You can also experience it. Because while you're doing test of any engine, you have different sensors like oil sensors. Will also find out the level of the oil, and it will also help you to find out the temperature of the oil, pressure of the oil. Accordingly, you will also take a corrective action if it is not going within the limit. This is a fuel gauge sensor, which will sense the fuel level, and also it will also help you to ensure that the level what is been required is been maintained in the fuel tank. And the fuel gauge sensor basically it operates with the help of a resistor output into the microprocessor, and based on the needle movement, based on the turning and then also the movement, it also helps you to sense and find out the level of the fuel, and accordingly the level can be either empty, full, or in between. Okay, accordingly you will also get an indication in your dashboard. This is a very important thing, sensor called throttle position sensor, because the throttle body is the one through which the air enters, and the air is required for both IC engines, for both gasoline and also diesel. And you see here, this throttle position sensor is a sensor which is used to monitor the position of your throttle, and the sensor is usually located on it's located on the spindle, so that it can directly monitor the position of the throttle valve. And this throttle valve is been basically meant for allowing the air, and the quantity of the air allowing can also be done with the help of throttle position sensor. Accordingly, this throttle position sensor will help you to position the throttle valve getting open, so that the air enters into the system. We have the crank position sensor, which is used to monitor the position or the rotation speed of the crankshaft. And once the crankshaft rotates, the camshaft also rotates completely. You're going to get the power which you're going to develop. And this sensor is very much important. And this helps you to control the ignition timing system as well. When I say the control system, basically the engine control system, it's based on the electronic control unit. This ECU is also applicable for other apart from the powertrain or the engine. So you have body control unit also, body control module, and also vehicle control module. This is how the typical ECU looks. Okay. With respect to the powertrain point of view, basically the engine, this electronic control unit, what we call as ECU, will help for the configuration of maintaining the power efficiency, mechanical efficiency. Yeah, because power is basically also depending upon the torque of the vehicle, and for which it will also help. And maintaining the heat balance, we have seen the heat balance formulas, calculations, and thermal efficiencies. The smoke, okay, smoke is very much important. So when I say efficiency and the power, it is related to air fuel ratio and also volumetric efficiency. When I say the thermal efficiency, it is related to the specific consumption and also the specific output. When I say volumetric efficiency, it is based on the specific output and also based on the airflow, how much is the amount of air entering into the system. When I say smoke, it is also based on the effective pressure and also based on the torque, how much you are going to experience in an engine with respect to different operating conditions. So these are the different components that are being involved with respect to the ECU. We have the power supply, in which the digital and analog sensors are there. We have the microprocessor processing unit and also the memory. We have the communication link, what we call as CAN. You have also seen in CAN in OBD2 as well. And you have the inputs, frequency inputs, discrete input, analog input, output of switch, pulse width modulation output. You have, based on all these components, you are going to get the communication in much more effective manner, and accordingly can also get the output. Okay, this is the block diagram of a monotonic engine management system. Basically, the torque controlled structure is been taken from a bus handbook. Okay, so this basically power is basically 2 pi nt by 60,000, what we call basically torque and power directly proportional. But at the same time, uh, you get higher torque when the speed is lesser, and when the speed is higher, you get lesser torque. So, and again, you get higher torque in between the intermediate speed. But irrespective of that, this torque is also very much essential for maintaining the power. And this you need to control the torque. So accordingly, you can also control the power in your vehicle, in your engine basically. And for controlling the torque, you have the engine management system, which will perform with the help of the CIN communication protocol and also ECU. And for here you see this is the driver which is doing which is they operating the vehicle. Now here as we are dealing with engine management system, so an engine mostly the very important key aspect in engine is the power, for which the torque is very much important. And the driver is giving the demands with respect to the torque. It can be both internal and also it can be external. So let us see the internal torque demands, which includes the engine startup. Again, it can be something related to the idle speed control, the engine speed limitation, engine protection, and the external torque can be with respect to the vehicle dynamic control or the drivability of the vehicle. And these are the demands with respect to internal and external aspects um, of an engine, and they're giving that to a system of a which demands the torque input, and also it gives us output. Say for example here, whatever the input we are going to get in the form of internal and external, it is just calculated based on the request of driver, and based on the engine configuration and the system configuration of the engine, respect to the number of cylinders, the power, and then the size of the engine, you get the desired torque. Okay, because you have different torque. Okay, all the engine will not be having the same torque. Okay, and the torque will vary with respect to the configuration of the engine, the size of the engine. Okay, and again the capacity also, because you have different CC or the liter what you call. Even that will also determine the different torque for a different engine. So accordingly, you get a torque conversion using the input what you're going to get out of the internal and external aspects, considering the engine configuration and also the size. And even accordingly, you will also get you can also maintain. You can also ensure that you're going to maintain the torque. Say for example, some vehicle will have 120 Newton meter, and some vehicle will have some engine will have 240 Newton meter. So usually 140, 120 is almost half the 240. Accordingly, the timing or the injection timing or the injection quantity, okay, or the fuel quantity injection getting injected into the system, everything will get vary. And what is expected out of this control system is that you need to maintain the torque. Even the torque should not be higher. If you are experiencing, if your request, if your specification is only 120, if you are increasing the torque beyond 120, say for example, if it is going 125 or 130, then you get abnormal torque. Okay, and again this may lead to overload. Okay, and again you may experience some failure as well. So you need to have the limit. You should also limit the torque. At the same time, you should ensure that the torque is not going below the limit as well. Because if the torque is going below the limit, then this will also affect your power. So this is why the engine management system is playing a vital role, and this will help to maintain the torque. And you see, this is a quite interesting block diagram, which explains the torque control in engine management system based on the driver inputs, and you are going to get the output in the form of the vehicle moving in the road. And so you have different system, gearbox, engine, and the chassis. So here powertrain, which we normally comes both the gearbox and the engine. And now we are going to deal with respect to engine, and the torque, what we are going to experience is with the help of the engine. And you see here with respect to the engine, you have the control unit called ECU, and the requirements of the engine with respect to the torque. As I said, you have both the internal and external torque. And again, based on the torque, we're also going to give the target based on the size of the engine. Okay, so and again you see here, even you have different gearbox application as well. Okay, so for example, first gear, second gear, third gear, fourth gear, fifth gear, or sixth gear, whatever it is. So with respect to different gear, the torque will also vary with respect to the engine as well as the vehicle. So again, the with respect to the complete vehicle, even the shift torque requirement is also given as an input. In the previous case, you are considering only the engine, but here engine along with the shifting of the gears as well. Okay, even this also be taken as an input. What is the overall requirement? The total torque requirement based on the steering effort and also the shifting and torque. And also you also have the target speed. Okay, so say for example the vehicle will have a target speed of 90 km per hour in India, and in the case of US you have 140 km per hour, and in the case of Europe you have 120 km per hour. So and again, according to the driving cycle or driving pattern of the cycle, so you should also have the target speed, and according to the target speed you also have the different gear and the different vehicle requirement. Accordingly the shifting of the gear or the torque requirement will vary, and if the torque requirement is varying, accordingly your target torque will also get vary. Okay. So what is important here is, as I said, you should limit the torque within the target torque. At the same time, you should not you should ensure that the torque is not going very less also, because if your target is going very much lesser than the expected torque, then you may experience less power, and you not experience the, the power output of our your engine. Basically, vehicle you get what you get out of it. Okay, we will see sensors and actuators again in depth. Okay, so I have a separate PPT. I will just give you overview about sensors and actuators in depth again. Before that, I will give you calibration tools that what you have for engine management system. Basically, this calibration tools you have different tools Inca, Visu, different softwares are there which is being used by different companies, service providers. Basically, the BAS or Delphi, what you have. Basically, this is how this is one of the layout or one of the snapshot that I have taken with the help of the software called Inca tools. It's basically a tool which will help you to calibrate your engine, to fine tune your engine. Okay, basically this is basically for fine tuning your engine for a better performance. That's why we are going for the calibration activities. That is been a part of engine management system as well. This is, you have different features. This is one feature. So here this with respect to the fuel pressure, you are going to get all the information. So once you connect your tool to your engine or to your system, what you get is you get all the with respect to these parameters in the calibration tool. So you have different subdivisions as well. And based on the command, what you are going to give here, the command is fuel pressure, and you will get different maps. Okay, maps in the sense with respect to the different speed, different torque, different power. What is the fuel pressure? Okay, this map you can get it mapping in the sense. Say for example, when the engine is running at 1400 RPM. Okay, and this is the fuel quantity. Okay, and with respect to this is the pressure. What you're going to get the fuel pressure. Accordingly, you can also find out. So this should be whether this requirement is within the specification or not. If this is not within the specification, then accordingly you can also find out some of the fine tuning activities, how you can correct the underperformance of the engine, and accordingly you can take corrective actions as well. And this basically helps you to do the fine tuning with the help of engine management system. So again, as I said, get the mapping with respect to the tools. There are different tools used by different companies. For example, Delphi uses this tool, and BOSS prescribing Inca, ADAS, what has been said. And you see, this is one another graph which indicates manifold absolute pressure in one direction, speed of the vehicle in another direction, and then the angle, and basically the spark angle. What you have the spark gets ignited, and again it also indicates the angle at which it gets indicates. Okay, so accordingly we also get the mapping, and we can also find out at the different RPM manifold absolute pressure. Accordingly, you can also find out that you can also fine tune if the pressure is below. You can also do the fine tuning, and accordingly you can ensure that you are going to get a good torque, which means you are going to get a good power, which means you are going to get a better performance as well. At the same time, even if sometimes you experience uh, more fuel consumption, okay, so you can also find out using these tools. You can also find out what is the reason why it is going in the higher limit or the lower limit. So brake fuel consumption or brake physical consumption also can be adjusted with the help of the tools. Okay. You have different phases for a calibration. Okay, so the calibration indicates engine calibration and also the vehicle calibration. So with respect to engines, what we do is we do the base engine and fuel emission optimization. Basically, it is also based on the emission point of view, not only with respect to performance. Performance indicates the torque and speed or the power what I am mentioning, and even this is also applicable for engine emission point of view as well. Basically, they do the modeling, mathematical modeling to ensure that in calibration is done in a more effective manner to ensure that the emission is also going at a low limit as well. And even the fuel compensation strategy is also being a part of the engine calibration. The air fuel ratio. So you have three type of air fuel mixture: clean mixture, rich mixture, and stoichiometric mixture. According to the different thing, uh, your, your your performance and also emission will vary. So in the case of rich mixture, you have more fuel and less air. When you have more fuel, obviously the emission will be on the higher side. When it is a lean mixture, the emission will be lesser, but the power is also going to be lesser. So you have different aspects considering the different parameters of the air fuel ratio as well. Okay. With respect to the vehicle, what is important is so with respect to vehicle, what you are going to see is the complete vehicle as a whole, the drivability and emissions, even onboard diagnostics. Okay, so we have seen the OBD. Okay, where we have different diagnostic tools. Even this is also a part of calibration. It's basically vehicle calibration activities. Not as I said, you have different module different diagnostic tool trouble codes for engine for not for a powertrain, body, chassis. This comes under vehicle calibration. And you can also do you need to do the monitoring, and finally you can do the testing and validation. Okay, so with respect to the calibration procedure is concerned with respect to the engine, you normally do it in the help of the test bed. Okay, where you can test it using a gasoline or diesel engine or a CNG or LPG engine, or using alternate fuels, vegetable oils along with the diesel biofuels recall. You can also test it using an engine as well as using the vehicle. Even you can also test it using a basis dynamometer. And the validation or the test is based on optimization. Okay, and also not only based on optimization, but also based on the type of the engine what you are going to use. And you have different parameters that you need to measure. As you said, it's not only performance but also emissions. In performance, you have a lot of things. We have seen a lot of performance parameters with respect to the efficiency, with respect to the power, and also with respect to the fuel consumption, etc. To understand the specification of your engine, you need to see what is your engine test limit you should have. You should also find out the specification initially. You should have the standard operating procedure for running the calibration activities. And okay, when you're going for the calibration procedure, first important thing is the specification. So all this comes later, but I forgot to tell the important thing. The specification, which is nothing but the target. Okay? So you need to shortlist or you need to finalize that specification. Based on that, you can plan for a test. Okay, and you can find out the test considering the validation plan. But what is important is the specification with respect to the speed, the torque, power, and then what is the best, what is the mileage you are going to get for a particular vehicle or particular engine, and then the other aspects. Okay, and with respect to emission point of view, and again, you also I told you you need to have the software for all these things. And again, the software is big activity. It takes a lot of time. You need to look for a lot of trials for carrying out the validation of the software. So you need to measure. You need to have the platform for the software activities for carrying out for in order to respect to the engine management system. You have separate team as well in any companies. And here, what you do is you need to collect the data. You need to collect the data, and you need to do the validation. And even you can do the mathematical modeling also. Help of modeling, what you can do is that you can also find out all the parameters with respect to the fuel emissions optimization, and also the strategies whatever have been mentioned. So you can also find out with the help of modeling. You can also do it virtual validation as well. You don't need to do it physically with respect to the specification what is available. We have a lot of virtual validation with the help of AVL software. You can also do it. You also have some amount of software with respect to Ricardo. You can also have that as a platform to carry out your validation. And you can also do it in a physical validation using the chassis dynamometer, where your vehicle is been connected to the help of a chassis dynamometer, and you can measure all the parameters, performance parameters, and also emission parameters with respect to different gears. So here normally you can also shift the gears 1, 2, 3, 4, 5, 6 accordingly. You get different power, different speed, different emissions at each gears. What is the performance? What is the emissions? You can also find out, and you can also optimize it based on some of the factors what you are going to experience while you are testing with help of the test dynamometer. This is one snapshot that I have taken is the software of calibration tool. So say for example, this can also be helpful for to find out when the cranking is going to begin and when the engine is going to start. What is the time required to start the engine, and what is the time required to reach a particular RPM? And this software will also help you to find out the injection timing and also the injection quantity as well. And in case if you want to increase the fuel quantity, or if you want to uh, increase the timings, you can also take corrective actions according to the inputs what you are going to receive with the help of the software or the tool called calibration tool. This is one snapshot that I have taken, which is indicating a system of injection timing in terms of microsecond, and also manifold of substrate pressure in terms of kilopascal. Considering the speed and then the timing, you can also find out optimization way how you can also increase or decrease, or how you can optimize it such a way the power and then the performance is not going to affect. If in case the performance is not getting affected, obviously you can also have a control over emission also. Here you are also going to get an input. For example, you are going to get an input when the crank is going to begin, when the engine is going to start. So what is the injector pulse of the injector pulse? Is it reducing progressively, or is it increasing? When injector pulse is going to get decrease, your carbon deposit will also going to get increase. So accordingly, you also should have a control over it as well. And at what degree your crank is going to get ignited, and what is the cranking fuel? How is it in phase or out of phase? And once the engine starts, when you are going to get the required manifold absolute pressure of the specified limit, what is the time duration. So all these inputs have been obtained with the help of these calibration tools. Accordingly, you can do the fine tuning. Again, this fine tuning will help you to improve the performance. Okay. These sensors and actuators are different topics. We have seen some of the sensors like oil pressure, oil sensors, oxygen sensors, manifold absolute pressure sensors. But there are a lot of different sensors that we have. So you will see those things, and even you will see some of the actuators as well. So with respect to the vehicle, you have different sensors, like you have the road wheel sensors, you have the sensors with respect to for whatever is required with respect to driver input. That all these have been required in the form of sensing, and for which the sensor is helping. And here the microprocessor is very much important thing, which gives you the signal with respect to the different system. It can be with respect to engine or transmission or vehicle, or with respect to the vehicle dynamics as well. This started in the year 1950, where you have the oxygen sensors for access for analysis. Then you have the electromechanical pressure sensor. Yeah, in the year 1970, you had the first silicon-based pressure sensor. Then now what we are having is the angular sensor or rollover sensor. So as the number of years is getting increased, the advancement is also going to happen. It's happening in the spirit sensors technologies. Okay, so you have different suppliers, okay, for the sensors as well. So you have the Denso, Delphi, Siemens, Bosch. These four are very much important supplier. They are playing a vital role across globe. I'm not sure whether anyone of you are working here, but I know somebody working in Bosch. Maybe you can also have interaction among you, so that you can also understand technology being used across your company. And you can also have the interaction among your colleagues. Even you can also teach me as well, if in case you can message me. Suppose if you are working on this sensors technologies, you can also message me, so that I will also learn from you. It's like a learning can be in both ways. Uh, so what is a sensor? There is a difference between sensors and actuators. Okay. First, we see sensor. What is a sensor? The sensor basically it converts a physical quantity into a electrical output. Okay. You are going to convert the physical or chemical, whatever it is, quantity, okay, in terms of whatever the quantity. Say for example, the fuel level, what I told, is the quantity. Okay. The oil pressure is a quantity. Temperature is a quantity. It has some value. Okay. Quantity is nothing but a value into an electrical quantity. Okay. Electrical quantity is nothing but a quantity which is having a non-electrical intermediate stages. Say for example, uh, the alarm what you are going to get. Okay, the indication. Say for example, you are going to get a globe, the red alarm, or a light indication, or a buzzer sound. Okay, it's basically coming out of the electrical output what you are going to get. So here the sensor is the one which converts a physical or a chemical one. Basically it's a non-electrical quantity into a electrical quantity. Basically you are going to get an output in the form of electrical. Whereas the actuator, what that is a actuator term. Actuator is the one which converts the electrical quantity into a physical one. Okay, you have different actuators. Okay, we will see those things as well with some of the examples. Okay, so actually just an opposite what I've been told, what I've been telling with respect to the sensors. What they do is that they convert the low power signals into an operating signal in the form of a quantity. It can be a physical quantity. So for example, to measure the vacuum, you have the actuator. It can be again hydraulic actuator, pneumatic actuator, electrical actuator. You have vacuum pump. So suppose to find out the vacuum pressure. So the output you're going to get the pressure is a quantity, okay, and the input is again basically the electrical signal or a signal what you're going to get in form of and the electric or non-electric kind of thing, and the output you're going to get is a pressure in terms of kilopascal or bar or Newton per meter square, whatever it is. So uh, that is an output which is coming as in the form of quantity, which is nothing but a physical quantity. And this is how the actuator is going to perform, which converts the signal uh, from electrical from a from a signal of electrical electronics into a physical or a chemical quantity. So you have different type of energy here. You have electrical, mechanical. Even the output can be either the form of electrical. I told only electrical, but even can be mechanical or even can be fluid or it can be a thermal. So these are all the sensors that normally use: pressure sensor, flow sensor, temperature sensors, presence sensor. Basically, for doing any test, you can also use the different sensors. So with respect to vehicle, you have different categories, and we are going to use the major area of system application for automotive sensors considering the usages. See, all these things I uploaded, you can also have a look over it. I will just cover only the important sensors. We also covered the actuators as well. These are all the different control system, engine control system with respect to the different functions. And you have the sensors, like for example, for the cylinder, you have the sensor to measure the pressure and also what is the combustion gas and current as well. For a manifold, you can find out what is the manifold absolute pressure and what is the temperature of for the flow. And for measuring the boost pressure of turbocharger, you have the pressure sensor. For measuring the engine knock, you have the vibration sensor. And for measuring the air intake quantity, you have the mass flow rate sensor, volume sensor. So you have the different sensors for the individual application. For measuring the for the throttle body, for the throttle position sensor, where you have the rotary position sensor. You have for the case of fuel injection system, you have the pressure sensor to measure the fuel injection pressure. So we have seen some of the diagnostics on board diagnostics, as well, missile, catalyst, oil as well. And to measure the fuel tank quantity, what is the fuel? You have the fuel gauge sensor. So all these are very much important important sensors that are being used in engine application. So these all the sensors you will study in automotive control system. Automotive control system is also quite interesting subject, but it's mostly of fully based on the control system activities, where you get a lot of mechatronics topic also there. Okay, you have a lot of sensors in the form of piezoelectric device, piezoresistive device, potentiometer, magnetic bus generators, and also Hall effect sensors. We have a lot of applications. Say for example, with respect to the Hall effect sensors, what we are using in the case of engine. Uh, we also seen in the last class, we have seen the lubrication system, lubrication and cooling system, where you have the thermostat. The temperature of the thermostat is less than 90 degree. If the temperature of a coolant is less than 90 degree, the thermostat will not open. And if it is more than 90 degree, the thermostat valve is open and coolant will go to the radiator. And if the temperature is less than 90 degree, the flow will not go to the radiator, it will go to the engine in the bypass valve. So this coolant temperature sensor will sense accordingly your thermostat valve getting opened or closed is based on this sensor. This is the manifold absolute pressure sensor. This manifold absolute pressure sensor works on the principle of electric and the capacitive principle. And this is one of the sensors which is being used for the electronic control system. So engine that uses manifold absolute pressure are being typically fuel injected. And this provides the manifold pressure information to the engine control unit. And this is necessary. Manifold absolute pressure map sensor is necessary to calculate the air density and also to determine the mass flow rate of the engine. This is how it looks. We also have the knock sensors. Basically, we have also, I have told you about knocking, detonation. Those things can be measured with the help of the knock sensors. This works on the principle of piezoelectric principle. You have the crankshaft position sensors, which on the principle of permanent magnet. That is lateral position sensor. This is how it looks. So oxygen sensors to measure the oxygen level. This works on the principle of having the coating, ceramic coating, the heated element is having. See, these are some of the principles that you can also have a overview, but no need of in depth. But again, you will be studying this topic in a control system as well. With respect to the airflow, your output voltage also going to be higher. So you need to do the calibration even for your sensors as well. Otherwise, you will not get the proper outcome. Okay, so the next important thing is actuator. You have linear actuator, rotary actuators. So you can find, but what is important is how the actuator works on what basis. You also have hydraulic actuators, pneumatic actuators, electrical actuators. So you will see some of the actuators which are there in engine application. These are the actuators which are working on the solenoid based principle, basically fuel injector. It is basically actuator what you are using for injector. Fuel injector is the one where you are going to get the fuel injection pressure. I told you the output you are going to get in the form of physical quantity or the quantity in terms of fuel injection pressure. Pressure can be either in bar or millimeter or Pascal or kilopascal. So this is again going to be an output, and input what you are going to get is an electrical signal. Okay, so you have the electrical input. Based on that, you are going to get the physical output. So that is what you call this as an actuator. We also have an EGR actuator, exhaust gas distribution actuator. EGR, is used to reduce the NOx emission. And here, the actuator what we are using, it's a variable position valve that regulates the EGR as a function of a check valve. You see here, the exhaust gas which is coming out, it gets regulated, the EGR valve will open. Accordingly, the exhaust gas gets recirculated to the intake manifold. The quantity of exhaust gas recirculation, okay, which happens with the help of a valve, and the valve is being one of the example of actuator. And similarly, the throttle valve also. Okay, you have a throttle position sensor, but throttle valve is basically actuator. Okay, again, it actuates, and accordingly it functions to give you the output. Here it works on the principle of the solenoid-based actuator principle. Here the solenoid is getting energized, thereby the current supplied by the control system flowing through the coil, and then the EGR is getting opened by applying the vacuum. You have different actuators, like it can be applied hydraulically, it can be applied electrically, or it can be applied vacuum. So here it is applied with the help of vacuum. And you see, the output you are going to get in the form of the quantity. It can be either electrical, or it can be either hydraulic, or it can be pneumatic, or it can be any fluid kind of thing. Not necessary to be electrical alone in the case of actuator. Okay. Okay, so this is a document that I uploaded. You can also have a overview, but give more importance to the sensors and the actuators which are necessary, relevant only to engines. No need to concentrate on the vehicle. Just have a glance over this topic.